The second important concept of curve sketching is global and local extrema. The word extrema is the plural of extremum point. It means extrema means extremum points. So we have two kind of extremum points. One of them is global, in other words absolute. The second one is local, in other words relative. Okay? We have either global maximum point or global minimum point. So let's look at these four definitions. We say f of x has an absolute or global maximum point at the point C if f of x is equal or smaller than f of c for each x in our domain. We say that the function has a relative or local maximum at the point C if the function is equal or smaller than f of c for each x in some open interval around C. So these two definitions are slightly different. In the first one, the domain is the domain that we are working on. Maybe it is closed domain, closed interval, maybe it is open interval, it depends. But in the second one, we must have an open interval around the point C. This is the difference. I will show this difference in this figure, in this graph. Okay. Let's look at the third definition. We say that our function has an absolute or global minimum at the point C if our function is equal or greater than f of c for each x in our domain, and our function has a relative or local minimum at the point C if our function is equal or greater than f of c, again in some open interval around C. We must have some open interval around C. Okay, let's have an arbitrary function. Let's say we have something like this. Okay, let's say this is our function f of x. Okay, let's find all global and local extrema. So let's say this is the point A, this is the point B, the point C, D, E, F, and G. We have many points to look for. What about the point A? Is it global minimum point or not? It is not the global minimum point since we only have one global minimum point if it exists. Sometimes it does not exist. The global minimum point is the point G, global minimum. What about global maximum point? We only have one global maximum point. This is D. Global maximum. Okay. Okay. We may have only one global maximum, one global minimum point. Okay. What about local points? What about local extrema? We may have many local extrema points. Is the point A a local extrema or not? It cannot be a local extrema. The point A cannot be a local extrema since we do not have an open interval around the point A. Look at the left hand side of the point A. The left hand side that is not included by the domain. The function is not defined there. This is why we don't have some open interval around the point A. This is why A cannot be a local extrema. Okay, very clear. What about the point B? We have an open, let's say some open intervals around the point B. This is why B can be local maximum. What about the point C? Using the same idea, the point C is the local minimum point. What about the point D? The point D is also a local maximum. A global maximum point can also be a local maximum point, no problem. Okay, it's not must, but can be. If the global extrema occurs at the endpoints, in this case, it cannot be local. Okay, if the global occurs at the endpoints, in this case, it cannot be a local extrema. What about the point G? We have a local minimum again. What about the point F? We have a local max. The point G cannot be a local extrema since it is endpoint. Okay, very clear. I hope you understand this part. If you have any question, write your comments. Now let me continue with an example, famous example. Let's say we have a parabola x square and we have three different kinds of domains. The first domain is the closed interval -1, 2. Let's say this is the point -1, this is the point -2, 1 and 2. Okay, so the first domain is from -1. Let me draw the function to the point 2. Okay, this is the domain from -1 to the point 2. Okay. On this interval, as you see, we have this minimum point. Is it global or local? Is it actually a global minimum point? Global minimum point, but it also can be a local minimum point since it is not an endpoint. It is not endpoint, okay? What about the point -1? Is it the small? Is it the biggest? No, it's not the biggest. This is why it cannot be global. Is the point 2 the biggest on this interval? Yes, it is the biggest. This is why this point is the global maximum. Is it local maximum? It cannot be a local maximum since it is endpoint. So 0, 0, the point 0, 0 is the global minimum point, also local minimum point. The point 2, 4 is the global maximum point. Okay, if I change the domain, if the domain is from -2 to 2, so this is the new domain. Okay, in this case we have two global maximum. This is -2, 4. Actually the point is the same. Okay, the point is 4, the value is 4, but we have two global maximum points, -2, 4 and 2, 4. Global max. Is it also a local max? It cannot be a local max since it is endpoint. So if you extend the domain from -infinity to infinity, if you extend the domain, in this case you do not have global maximum. Okay, you cannot have a global maximum. You only have global minimum or local minimum. In this case 0, 0 is global minimum point, but we don't have any maximum point, any maximum extrema. Here we have two global maximum points, one global minimum, 0, 0. Here we have one global maximum point, 2, 4, one global and local minimum point, 0, 0, 0, 0. So I hope it is clear. Let's look at the second example, cosine function. I think you know the graph of cosine function is something like this, right? And it is periodic. This is the point 1, this is the point minus 1, 1 and minus 1, right? So it's something like this. It is not, it is something like this. If you look at the graph of cosine, you see that cosine function has extrema, relative and absolute, that occur at many times. Many times. Cosine function has both relative and absolute maximums of 1. Okay, this is the point 1. At the points, let's say minus 4 pi, minus 2 pi, 0, right? You can continue 2 pi, 4 pi, and you can go on. Also, you can go on from minus infinity, right? You have many points that make the cosine function maximum, relative or absolute. You also have many points that make cosine function minimum, and the relative or absolute minimum of minus 1 occurs at the point, as you see, this is the point minus 1, minus 3 pi, minus pi, you can continue on this, pi, 3 pi, all odd numbers, okay? You have infinity numbers of points that make the cosine function minimum, okay? It is the last example for maximum and minimum points. Now let's look at this strategy. How do we find an absolute extrema of a function on a closed interval? Okay, we have a strategy. First, verify that the function is continuous on the given interval. Then find all critical points of f of x in the given interval. And finally, evaluate the function at the critical points and at the endpoints and compare all of them. Now let's look at this example. A polynomial is given here. Two different domains are given. Let's first focus on the first domain. Let's look at the strategy again. Verify that the function is continuous. Yes, the function is continuous since it is a polynomial, no problem. The second step, we find all critical points of f of x. In order to find the critical points, we take its first derivative. Let's find the first derivative of f of x. The first derivative of this function is simply the parenthesis of 6, x plus 2, x minus 1. As you see, we have two critical points, minus 2 and 1, as you see, critical points, okay? The second step is also done. Evaluate the function at the critical points and at the endpoints. So, evaluate the function, not its derivative. So, f of, we need to find f of minus 2. What is f of minus 2? If you calculate, you see that it is 24. We need f of another critical point, f of 1. Okay. If you calculate, you see that this is minus 3. We also need f of minus 4, since it is endpoint, this is minus 28, and finally f of 2, other endpoint, let me clear this one, f of 2 is equal to 8. Okay, so we have three values, 24, 8, minus 3, and minus 28. Which one is biggest? Which one is greatest? The greatest one becomes absolute maximum point. So in this case, the absolute maximum of f of x is 24 at the point minus 2, 24. Okay, and absolute minimum point of f of x is minus, since it is the smallest one, this is minus 28, so it occurs at the point minus 4, minus 28. It's all. Okay, it's all. What about if we have this domain 0 from 0 to 2? We already computed derivative of f. We already find the critical points, right? We have two critical points. So we have to check the function. We have to be careful. Are these critical points in the domain or not? Is minus 2 in the domain? No, it's not. So in the second case, minus 2 cannot be computed. Minus 2 will be ignored. What about the point 1? Yes, the point 1 is in the domain. So we only have one critical point to compute. We need to find f of 1. We already computed here, right? F of 1 is minus 3. And we need to compute the function at the endpoint of the domain. We have new endpoints. One of them is 0. If you calculate f of 0, you see you have 4. And the other endpoint, which is calculated here, is 8. Now we compare three values. Which one is biggest? Which one is smallest? The biggest one is 8. The smallest one is minus 3. So absolute maximum point is 2, 8, and absolute minimum point is 1, minus 3. This is the absolute minimum point. So this is all. We have a test which is called first derivative test for local and relative extrema. Now the previous one was for the global extrema. Okay, this one is for local or relative extrema point. Let's look at the test. Suppose that the point C is a critical point of f of x. Okay, in this case we check the sign of f prime. We check the sign of f prime. If the sign of f prime is positive, this is the sign of f prime. Okay, if the sign of f prime is positive to the left of the point C and negative to the right of the point C, in this case x equals C is called a relative maximum point. Okay, what about the relative minimum? If the sign of f prime is negative to the left of C and positive to the right of C, in this case the point C is called relative or local minimum point. Okay. If the third one, if the sign does not change, if you don't have any change, when we talk about sign of f prime, in this case we do not have any local extrema, no local extrema. Okay. If the sign of f prime is the same sign on both sides of the point C, in this case C is neither maximum, C is neither relative maximum nor relative minimum point. Now let's look at this again. Polynomial function, we need to find f prime and check the sign of f prime, right? F prime is equal to, it's not so easy to calculate f prime. This is f prime, and we make it equal to 0 to find the critical points. We have two critical points. The first one is -2 and the second one is 2, right? Okay, these are the critical points. So let's find the sign of f prime. Let's have this point. This is the point -2. This is the point 2, and I need to find sign of f prime in these intervals, right? So what about the sign of f prime from -infinity to -2? I pick an arbitrary point. Let's say the point -3. -3 is in this interval, right? So the sign of f prime of -3 is positive. You don't have to calculate the value of f prime at the point -3, but we have to know what is its sign. Okay, the sign is positive. What about the sign of f prime from -2 to 2? From -2 to the point 2. I also check an arbitrary point. Let's pick the point 0, since it's a very simple point, and plug. Then you have -12, which is a negative number. Okay, I want to choose the point 3, and then I see that this is positive. Now let's look at this definition. F prime is positive, as you see, to the left of -3, and negative to the right of -2. This is positive to the left of -2. This is negative to the left of -2. In this case, -2 becomes a relative maximum point for this function. This is positive. Again, f prime, the sign of f prime is negative to the left of 2 and positive, look at this case, and positive to the right of 2. This is why the function has a relative minimum at the point 2. Okay, it is the idea of first derivative test. Okay, so since f prime is positive, the function must increase. The function decreases here and the function increases here. This is also another way to choose the maximum minimum. See, this is the maximum point, this is the minimum point, and they are local extrema points. And the final remark, second derivative test for local extrema. This is the final test to find local extrema points. In order to use this point, we assume that f double prime is continuous on an open interval that contains the point C. Okay, it's the first condition. And we also say that f prime of c is equal to 0. Okay? If f prime of c is equal to 0, and if f double prime of c, the sign of f double prime of c is negative, then we say that the point c is a relative maximum point. If f prime of c is equal to 0, and the sign of f double prime of c is positive, in this case the point c becomes relative minimum point. Okay? Again, if f prime of c is 0 and f double prime of c is also 0, in this case the test does not work. It is inconclusive. We also can apply this test to find all relative extrema.